I just wanted to thank you for your video. For your videos.
Which the lecture videos?
Yeah, lecture videos.
Yeah, no
I just
problem.
wanted to thank you.
You're very welcome.
It's really helped me along with my project.
Fantastic. Very good. Okay, ladies and gentlemen, welcome back to EECS 498 Game Engine Architecture. This is going to be an exceptionally short lecture. The topic of coroutines, probably not one that is going to show up on your exam, but we still will talk about them today, at least at a high level. And for those of you who are familiar with Unity, and remind me, how many of you are out there? So many of you took 494 or 440. I think that you'll appreciate this a little bit more, right? Seeing how you could add Unity-style coroutines to your game engine today, if you wanted to. And so, let's go ahead and get to it. Some quick news. We have our first, I think, couple 100% on homework 9. So congratulations to those of you who made it through this last assignment. It didn't take you very long. Right? Does anyone want to, yeah. Is it hard? Or is it just short? What is it? Yeah.
It's not, like, difficult to do, but it's really difficult to debug.
Yeah, it's difficult to debug.
Yeah. Like, I feel like I found a version that I liked and was really fast.
Yeah.
And it does something that is analogous to what the autograder would do.
Oh.
But it's not the exact same thing the autograder does.
Oh, cheating.
So, yeah.
Nice.
It's just trying to figure out the way to do it.
Got you. Okay. One big thing to note is that the Homework 9 assignment spec has received a few updates over the past couple days. I didn't point all of them out, but if you look on it, the the assignment spec will now tell you, for instance, what order the mathematical operations are done in, or what order the particle transformations are done in. Do you apply gravity, to the velocity before you then use a velocity to update the positions, right? That stuff will affect the result. And so hopefully you'll be able to find that on the assignment spec. The test cases were updated late last night to be a lot more forgiving across the board. And so there are still a couple test cases that are trying to test things like your memory reuse algorithm. Because we do want you to use the one that the assignment spec prescribes. I've been very impressed with the performance I'm seeing out of a lot of your engines on this assignment. One of the cool things about this assignment is that given that we have access to all of your repos, when one of you discover kind of a unique new way to make things move faster, there's a chance that might get incorporated into the assignment staff solution for the next year. But maybe not. We don't want to make the assignments too tough. So anyway, for those of you who have not started homework 9 yet or are still in the early stages, the assignment is not a super heavy-duty, nasty thing, it seems. So hopefully that gives you a little bit of peace, okay? Is anyone else getting these weird, canvas rendering problems lately? Like this week, it decided to just crush my beautiful schedules down into this tiny little bar. Well, if you find this and you're annoyed, hopefully I'll eventually figure out the solution. But if you right-click in Firefox, at least, you can go to this frame, and then you can go to, just give me the whole thing. And you get the whole thing, nice, big screen, it looks great. So keep that in mind. A reminder of where we are. We're midway through homework 9. When we get to Monday, we will have a quiz. That quiz is going to be on the topic of Box 2D and some kind of light data-oriented stuff, okay? I don't expect it to be particularly difficult, but I think I've said that for a few quizzes, so it's just hard to say. In any case, if you have not caught up with the homework yet, know that data-oriented design homework number 9 actually goes all the way to Wednesday. All right, it was extended 2 days. That will not happen again next year, but just for you, you get it. And that next week is going to be mainly just about exam prep. You'll have plenty of time to study. Our lectures will be pretty light. Hopefully by next week, Monday, or at least by Wednesday, I will have all of the exam done so I can tell you exactly at least what topics will be on there or what won't be on there. Yeah, after the exam is finished, we will begin on some more miscellaneous topics. I'm going to try my hardest to get a lecture in on the topic of CMake, which is a highly in-demand topic. For those of you who love jumping from Xcode to Visual Studio to Make, back to Xcode because it didn't work, I'm so sorry, but CMake tries to eliminate that process, and it works. It is very popular in industry, because basically what happens is CMake, you configure CMake in kind of a platform-independent way, build system-independent way. You tell it where your dependencies are, you tell it where to look for headers, and then it will generate Visual Studio files for you, Make files for you. It'll generate an Xcode project for you that's just all ready to go and hooked up to everything. No configuration needed. You just double-click that Xcode button, the file, and then you click the little run button, and your project is building. That's it. Okay? This is all to say that the annoyance that you faced using all these different similar but not quite build systems is something that we've been dealing with for a long time as a species, and that has kind of sort of been solved. Okay? So hopefully you'll appreciate it. Hopefully you'll enjoy that lecture. I did not get any sleep last night, sadly. This was not a hard work thing. This was just a couldn't get myself to go to sleep thing. So I apologize if my vocals and speech patterns are a little bit strange and a bit delayed today. So we do have a game engine that I would like to show you. This is one that is kind of a little bit interesting given the course that's launching next semester. We are not going to be using the Blender game engine, but it does exist, and it is a very interesting engine in that it feels super cool, fully featured, and no one uses it. And I'm waiting for people to use it because the results really do look fairly impressive. You can see some footage here of a game that looks like a kind of a third-person action game. The way the character moves, the animations look extremely smooth. How the character transitions between animations, very impressive. And it should make sense. Blender is a ecosystem where you can very quickly create great characters and animations. And if only it was also a game engine, maybe we could make a full game out of it. Well, its initial release was in 2000. It was created by just the contributors to Blender, but the game engine itself was cut from Blender. It was chopped out, okay? It used to come default, built into Blender, early versions in Blender, but it was discontinued in 2019 because just no one used it, okay? I used it very briefly when I was in high school, and fortunately, it now lives on as an improved but separate add-on to Blender. It's called UPBGE. Now, wouldn't it be the coolest thing if this was developed in the Upper Peninsula? Now, that's not the case, okay? This is the Uchronia Project Blender Game Engine. And it lives on upbge.org. And they've got a very slick little website. Looks great, okay? The idea here, again, is we want to be fully featured. So you don't have to leave Blender to do anything. You don't have to export anything. Just keep it all in Blender and have a great time, okay? Fully integrated into Blender. 3D game engine forked from the old Blender game engine and deployed with Blender itself. Unified workflow, main strength. You can make your game start to finish without actually leaving Blender. So if you just love this program to death, as many people do, you can rock and roll. So you have access to all the normal Blender stuff and all the tools. You can make objects, you can create materials like you normally can, but you have kind of improved facilities for creating things like templates or prefabs, right? Or blueprints if you are in the Unreal mindset, and tools for kind of quickly bringing them out and placing them around, okay? You can then animate stuff, apparently very conveniently, and they just look very nice. They have a visual scripting system that if you've ever used Blender's shader editor, it looks very similar. If you've ever used Unreal's blueprint editor, visual scripting, blueprint visual scripting, or if you've ever used something like MIT Scratch, right, very visual, node-based, then that is how you write your logic, okay? Blender normally has support as well for Python. And so I'd be shocked if you couldn't also write some of your logic in Python if you wanted to. And we have some footage showing what looks like real indie-style gameplay. So what you can't really find is are too many fully featured games that actually use this, which is a shame. They have documentation. You can look up some guides. I'm sure there are YouTube tutorials on this stuff. But yeah, it's interesting to imagine why it failed. I couldn't necessarily tell you. You'd think that Blender, plenty of people who start making Blender models want to see those models run around in a game, be interactive. But for whatever reason, that just didn't work out. It didn't translate, okay? They couldn't hook people using Blender and pull them over to the game engine side of things. No, people went for Unreal, they went for Unity. Even Godot is wiping the floor with this engine, as far as I understand it. It does bring the Bullet physics engine, which is one of the famous open source 3D engines, alongside PhysX and Havok. Havok is not open source. Yeah, so it uses Bullet yeah, so you can get some good physics integration as well. Okay. Distributed as a variant of modern Blender, the team basically grabs the most recent version of Blender, adds in their technology, and then just ships that. Okay, links that on their website. Okay, that's the power of the open source license they have. GPL is very scary, but as long as your project is also open source, GPL is no worry to you. Okay, again, reminder, the GPL is very scary for a lot of businesses because they don't want to open source the cool technology they spend a lot of money and time building. That's their competitive advantage. They open source it, and they might be toast, okay? So you might want to keep that in mind for future assessments relating to licenses, if any show up on the exam, okay? Yeah, so probably not viable for commercial use cases. Probably not. You never know. Full integration in the standard Blender editor. The scripting language is Python, but they also allow for visual code blocks, and they call them logic bricks. So kind of Unreal style stuff, okay? That's about all I have to say about the engine, and I have used it in high school, but it's been a very long time. I encourage you to give it a shot. When I was initially designing this course, I imagined an extra credit assignment where if you could get any engine like building and running on your laptop and demonstrate it and record a really quick video, you'd get like 1 point of extra credit. I decided that we didn't want to grade that. It's a lot of time watching lots of videos. And what does it mean? Like, what's significant enough, right? How much do you have to use it? Do you have to build a mini game with it? Do you have to build the shmup again? No, that's just too much work. You got enough on your plate, okay? All right, so some announcements, and then we will move on to the tiny bit of content we've got in this particular lecture. Yeah, that's the curse of being a new course. Some days are just absent. But if you need extra office hours, I'll be walking around. You'll get plenty of extra office hours, probably an extra hour of it today. Quiz number 5 is coming up on Monday. This is your final quiz, unless you consider the exam to be just a very big quiz, which you could. But this is the final quiz. And a reminder, we drop your worst quiz score. This is also actually what's happening is we find your worst quiz score, and whatever it is, we just jam it to 20. and so we max out your worst score. That's how we implement the policy. If you have been doing a really good job on your quiz and you want to take a break, this is your chance to take a break, okay? Just skip it, all right? And you will get that score maxed out if it is a 0, okay? 20 free points, just like that. Not too bad, huh? I would recommend at least looking at the questions because the quiz questions are a basis for what can sometimes show up on the exam. So keep that in mind. Okay, the topics are going to be box 2D. So I highly recommend just reminding yourself, what is a fixture, right? What is it used for? Okay, what is a B2 body def? How does that relate to a world? Okay, what's the hierarchy of all these objects and how they kind of work together to bring the simulation to life? Just review that stuff. If you've recently done homework 8 and gotten through it pretty well, then I think you're going to do just fine on this quiz. If you haven't reached homework 8 yet, you're still in homework 6 or 7, you still got a shot, right? You still got a little bit of time to get going and catch up. But it might be worth skipping ahead to read about some of these concepts, review the lectures, and just get yourself kind of mentally prepared for some of the questions that might show up. If you can't get all the questions, get as many as you can. Okay, and just do the best you can. Your grade might end up coming out better than you think at the end of the year. Okay. This is actually a note from last year, but it was really cool, so I wanted to show it to you. Last year we had students who didn't have a homework 9, so how are they going to keep themselves entertained? Well, they started on their custom feature early, and within like weeks before the custom feature assignments even began, we had students showing me web builds of my mini games. So here's a good one. You'll notice in this footage, it's running in Chrome in a web browser, right? And it's running really well. It plays well. The sound is playing, right? The inputs are going through, and super impressive stuff. Now, when I saw this and discovered how, realistic it was to do this, basically there's a compiler called mscripten that can take your C++ project, notice that it's using SDL, and you can configure it a bit, and it will create your web build. So it runs in WebAssembly. It'll give you a web page. This actually made me want to upgrade the autograder so that certain really cool test cases like this one would also give you not just video footage, but a play in your browser link. So you can actually play the game right then and there in your own engine, but just compiled to WebAssembly. So maybe if I get bored enough one day, I'll see how realistic that would be, because I think it'd be really cool to see your engine go and make a game come to life, and then say, hey, well, you can go play through the whole thing. The test cases are usually just a small portion of gameplay for storage limit reasons, but I'd like to make some of these games much bigger, kind of like a May and Mag style thing. We can have stickers for people who can get through it. It's going to be awesome. Anyway, all right, that's web export. Someone really quickly got joystick controls working. They wanted to implement controller gamepad support, so Xbox controller support. And so here you've got your 2 sticks and you've got your 2 sprites that are kind of showing you where they are. So super cool stuff. I love seeing this come to life. I love seeing all of you kind of go off the beaten path, the training wheels fully off, and just being able to see you all like integrating libraries and not having to ask questions to the staff or all that stuff. Like, that's a big deal. Okay, that is a huge deal. Nick Cerrone did us a solid. I told you earlier that a couple students made documentation for the entire engine. I just lost track of who it was and where to find it. So this is some documentation that was put together for the various APIs, names, descriptions, and examples. I might link this on the webpage. We'll see. In any case, yeah, super cool stuff. I don't think this would be enough for full credit for your custom feature. We do want you to do some engineering-related work and not just documentation-related work for your final 2 assignments. But yeah, it's pretty cool stuff. Very inspiring stuff. And then, of course, you occasionally get a student who goes ham, says, I'm going to make this engine 3D. We had a student say, I'm going to rip out Lua. I don't like this language. You know what language I like? Python. So they ripped out Lua and they embedded Python, recreated all the APIs. And so their engine alone is a Python 3 variant of the A2 engine. Absolutely sick. One of the final things you'll do in this course is you'll fill out a form to register your engine. As in, you'll provide a link to its web pages, its GitHub. You'll provide a link to its logo, a description, a name. And because that you fill that out in a Google form, we have a database forever in the form of a Google spreadsheet. And one day, we're going to start auto-generating a database web page so that your engine will be linked forever from here. I'll click that, and you'll be able to see everyone's engine, and people can check yours out in particular, right? Find the best one and use that for their Game Jam project. Sounds sick, yeah? So anyway, but one day. Okay, so coroutines. What are they? The mystery, the myth. Coroutines are one of the most powerful technologies for scripting, for implementing gameplay. That we really have, that we provide game designers access to. And in C++ 20, coroutines are actually a feature. Now, you don't use C++ 20 in this class, but you can use C++ 20 after you get to the custom assignments, right, in just a couple weeks. But the basic idea here is we want the ability to take a single-threaded environment, and we want the ability to have functions that can delay themselves, that can let other parts of our code base run while another chunk of logic pauses, right? Why would we care about this? Oh my goodness, I hate the syntax for, hate's a strong word. I strongly despise the syntax that C++ uses for coroutines. It is just nasty, okay? The basic idea is that you indicate a function that you would like to run. You'd like it to run kind of asynchronously, and it would be very nice if it could delay, okay? Here's an example right here. So in Lua, coroutines are actually a first-party built-in feature, just like they are built-in first-party to C#, which many of you are probably used to if you've used Unity, okay? So a coroutine kind of creates a point of execution. So you can see it here, co equals coroutine.create. You provide a function, okay? And you can then print this co, and you'll see you get type thread. This is kind of misleading, okay? This is not a multi-threaded situation. Lua is not multi-threaded. I think there are hacks that exist out there. So Stardock's Lua is multi-threaded, because they really need that for their large-scale games. But you've got this object called a coroutine. You've created a coroutine. What is it? Well, it's a function that has been suspended. If you print this coroutine's status using the function coroutine.status, you'll see that it is suspended. It's not running. Once you create a coroutine, you can stop it, you can pause it, you can do whatever you want. And so an example here is that if you call coroutine.resume on that coroutine object that you created, then it will run. And when this function runs and begins progressing, it will print hi, okay? You can check the coroutine status again and you'll get dead. It is finished. It's totally finished. It has run its course to the end of the coroutine function, and there you go, okay? So why does this matter, right? We basically have a function that can pause. It can actually halt. It can wait and let other code run. That is extremely powerful, okay? So here's another example. You have this coroutine object we're creating. We create it using the coroutine.create function. And we have this function in here that's a bit more complex this time, okay? It has inside of it a for loop that's going to go I1 to 10. So it's going to iterate quite a few times. And every time it does, it's going to go co, and then it's going to print the I right there. So we should see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It then yields. This function is very special. This is a function you can call within a coroutine that will pause the coroutine and let other things run. It's basically saying, hey, I want my function to chill. I want it to take a break and come back at another time, okay? So what happens here? Well, when you call coroutine.resume to run it, it's going to print co1, okay? You can then see that now the coroutine has yielded and now it's suspended. It's just chilling and waiting for you to resume it again. All right, you call coroutine resume, you get co2. You call coroutine resume again, co3, all the way to co10. At the very end, it's nothing, okay? Now, does this sound similar to what you get in Unity? Maybe vaguely so, but Unity's coroutines actually work a little bit different. And I'm going to go in and for those of you who don't know much about Unity or C#, I'm going to show you what that code, what those coroutines look like, and why you might want to use them in just a bit. But for those of you who have taken 494, who love coroutines in Unity, the big problem that Lua coroutines have is that nothing by default will resume your coroutines in Lua, okay? Imagine if Unity, right, you're writing a Unity coroutine, you write yield return null, and instead of it just resuming on the next frame, it never resumes. You actually have to write code to manually tell that coroutine to resume, maybe in an update loop. Oh, that's annoying. That stinks, right? Unity's setup is exceptionally nice. They did a great job, and so they made it very convenient. Here, this isn't convenient. Look at, I gotta call coroutine.resume like 10 times just to get through this coroutine. Very annoying. I wish it would just run, right? Come back on the next frame and run again. Or maybe I could change this to a wait for seconds, and we could have this resume every couple seconds. So what I'm gonna do for you is on this agenda, I've provided a coroutine manager that I wrote myself, and you can use it if you want to get Unity-like behavior back, okay? And I want to show you a game project, okay? I want to show you a game project that is going to recreate that Unity vibe for you. In this project, we simply have two things. We have a coroutine manager actor, which has its own coroutine manager component. This is what's going to give us the Unity-style behavior where if we pause our coroutines, they will automatically resume. We don't have to force them to get called again and resume again and all that nasty business. We have this actor called tester actor, and we have a component called tester. If we go to this component right here, you can see that in onStart, we call coroutine manager, okay, not coroutine, but coroutine manager, .create, okay? We provide the function that we want to call, okay, and then we provide the instance of our actor that we want to kind of run it and be responsible for keeping it alive and running, okay? We launch two coroutines here. One is the do AI function, which is right here, and the other is the do download function. The do AI function is super simple, okay? It's simply gonna run and it's gonna wait for 2 seconds and then it will print AI loop. And then it will wait for 2 seconds and then it will print AI loop. Wait for 2 seconds, AI loop, okay? Now, the do download is very similar, except this one will eventually end. We have this local variable in the function called times, like, rounds remaining, basically. While times is larger than 0, we decrement it. We wait for 1 second, so a slightly different cadence than the AI loop, and we print downloading. After we've done this a couple times, this downloading coroutine will finish, and it's gone. It's toast, okay? While the do AI coroutine will never end, unless some other code grabs it and destroys it, stops it, okay? And so, would you agree, those of you who have done Unity, this is kind of similar to the Unity API. This looks a little bit more normal. You're not having to call coroutine.resume all the time. Well, let's verify that this works, okay? I'm going to launch my homework 9. Oops, are you looking at the code right there? Let's see here. There we go. Okay, so let's go ahead and launch homework 9. Okay, and watch the output right here. Downloading. Okay, now downloads are finished. AI loop. A little bit slower. AI loop, right? This is the Unity style behavior that you are searching for. This is the style of behavior you probably want, the style that will allow you to write interesting gameplay mechanics that pause and occur over time and not necessarily over frames. Yeah?
Does this also have just a yield return null as an option for just one frame?
I think you can create that if you want to. I'll show you how in just a sec. Yeah. Yes. I think if you just do that yield, like coroutine.yield, I think it will return only for one frame. The coroutine manager will see it on the next frame, see that it's stopped, and launch it to resume again. Okay, so we've recreated Unity style, kind of nice, simple syntax coroutine behavior. I want to show you what the coroutine manager actually looks like. And for those of you who are familiar with Unity, hopefully you can get a feel. I commented it just a ton on how it works and what its job is, okay? So this is a component. You have to put it on an actor. This is a singleton manager component, so what does that look like? Well, if you recall from Unity, this singleton is in its onStart function going to check, hey, does this component exist? Okay, if it doesn't exist, if it's not equal to null, or if it does exist, then we don't want to create a second coroutine manager. So we need to enforce the singleton pattern, and we need to destroy ourselves. And that's what we do. Okay, we then return. However, if we are the first coroutine manager to ever spawn into existence, then we are going to create this global variable, our singleton, and we're going to set it to a reference to ourself, our actor. Okay, now this has been set, so everything that tries to get created after this, every coroutine manager that might try to load in is going to destroy itself, which is exactly what we want. We only want one coroutine manager, that is it. Okay, we call scene.don'tDestroy, which means this actor is going to be around forever, even if you change scenes. We then create two more global variables. Okay, we create a coroutines table. This is basically an array that's going to keep track of all running coroutines, okay? We then created an API. This is a global table because remember, this is all being done inside of a function, inside of a table, but we're not using self. So if we're not using self, that means these things we're creating are global, okay? We have a table we're creating that's global called coroutine manager. Inside of it is an important function called create. In this create function, you provide a function that is going to be your kind of coroutine, your function that's going to launch. You also, do you see this ... This is something you sometimes see in C++. It's basically saying, hey, whatever additional parameters you provide, it's going to be funneled through to something else, okay? So we create a new coroutine using the built-in Lua API. Right? New coroutine. We insert that into that global coroutine table to keep track of it. We then take our parameters and we're going to launch that coroutine that we just stored using the coroutine.resume. We say what coroutine we want to resume, and we also provide some parameters to it. We need to use table unpack because of the nature of this, basically this ... parameter. Is it like variadic, I think? I think that's what it's called. That basically can be one parameter or none or any amount of parameters, okay? Then what's going to happen is if the coroutine was launched successfully, we're all good. We return a reference to it in case the user wants to store it and stop that coroutine later. If it didn't succeed, we go ahead and just remove it right away and we display whatever error message caused the coroutine to fail, okay? Every single frame of our game, we need to look at what coroutines are suspended, and we need to relaunch them, okay? And this is the function that does that. We're going to look at what coroutines currently exist. We're going to iterate through that global array. We're going to look at the status of their coroutines, and if they are suspended, we're going to insert them into this little holding dead coroutine indices, and then at the very end, we'll remove all of those. The others, I think we resume. Okay, yes, we resume right here, coroutine.resume. okay? So this gets us to that kind of Unity-style coroutine approach, where you can launch a coroutine and just kind of let it chill, okay? This is all you need in your engine to kind of recreate this effect. Now, I've thought about homework 9 making it a bit longer and requiring you to make this happen. We could write coroutine-related test suite and test cases. I decided that it was kind of tangential to the particle system of homework 9. And I'm going to guess that a lot of you don't really understand all that stuff I just said. It's okay. And especially if you haven't done anything with Unity before, if you haven't taken 494, then all of this is probably very mysterious and confusing, okay? You don't really have to worry too much about this. If coroutines make an appearance on the exam in a week or so, it's going to be a very lightweight and very high-level question. Basically, do you know what coroutines are, right, or what they are meant for? If you do, you're going to be just fine, okay? If, however, you want your engine to be really useful, you want to actually use it to make games, a coroutine manager is what you need, okay? Extremely important stuff. So over here, you can see a couple interesting things. These are global functions that are basically functions you can call. They are designed to be coroutines. They will call coroutine.yield to pause themselves. And we have a function here where you can provide a number of frames to chill and relax, right? It will kind of count down how many frames are remaining, and it will yield to let the frame end. So Evan, you asked, how do you let the frame end? This is how you do it. Yep, coroutine.yield is basically, what is it? Yield return null in Unity. We have now a classic function from Unity, wait 4 seconds. Absolutely essential if you want to use coroutines in a pragmatic way. This actually is implemented by using the os.time function. And it basically just checks this every single frame and checks how much time has passed. If the provided number of seconds have passed, then we conclude the function, which will allow us to stop. Okay, these are the functions right in here that were being used in our tester.lua example. Do AI uses it, do download uses it. Okay, and so the syntax is slightly different. I find it a little bit more annoying of a syntax, but not too bad. Okay, the final key piece is that all of this that you see needs a way to run and check out the coroutines that are suspended and to relaunch them every single frame. And so how do we do that? Well, the way any other component gets its update heartbeat, okay? Using an onUpdate lifecycle function. From there, we call coroutine manager update, which will cause this update function to run right here, which powers the entire system, okay? I think the one thing I'd really like is for this to be built into the engine and not a Lua script that you have to download and put into every project. That kind of stinks, okay? And we could definitely do it. We could hard code exactly this, right? I could write a test case, in fact, where the only thing you need to do to get the points is just make sure that in addition to, for instance, loading all the actor templates into your Lua state when the engine starts, you have to load this hard-coded Lua text in as well. Basically, it's like a do-string call, except it's very annoying to copy and paste in. So I'd probably have to give you that code so you don't have to arduously, make typos and try and get it in there. In any case, yeah, would make the engine a lot cooler, I think. Okay, so that was a lot on these coroutines in the Lua context, okay? Does anyone have any questions on the Lua side of things? Because if you're confused about coroutines, I'm about to show you a lecture from 494. Okay, yes?
It's not necessarily a Lua thing, but just as a clarification for the final project. Does it have to work across all 3 platforms still, or can it be platform specific?
So as soon as you hit the final project, i.e. the final 2 weeks of the course, you're free. So you can choose to specialize on any particular platform that you want. Now, some students decide to remake their build process in CMake. That's one of the valid custom research features that you can do. So that gets you heavily into CMake. You learn a lot, and you get to forever say goodbye to messing with Xcode, which is pretty much a killer feature, I think. But you can do whatever you want. It's very free form. I will say last year it was very lightly and I kind of very gently graded. Okay, we're going to be very generous with what we consider research. Okay, and what we consider a significant feature. So it depends on how much time you have. But you can you can do whatever you want for the most part. So long as it's a little bit substantial. So long as it fits with all of the ideas we already give you. If you are curious, I have a preview of the assignment. Oh, do I? Maybe I don't. Is this staff 498I? Okay, let's look at the homework assignment a couple weeks early just to kind of get you excited about it. Okay, let's take a look. So here are some ideas. Okay, a basic scene or map editor. Okay, a lot of people integrate with like Tiled. To quickly get a map editor integrated, allowing them to tweak actors, move them around, alter their properties, okay? You might need to integrate XML library in order to import and process the actual tiled files. But tiled is how May and Mags was made, the web game at the top of the screen. So it's really nice. It's good. One of the easier ones that you can support if you don't have a whole lot of time is controller support. Okay, usually that means PlayStation or Xbox. I'm waiting for that DDR dance pad support myself. Okay, I really want to see that. But you do what you got to do. CMake build support. This might be one of the more pragmatic custom features that you could go for. I'm certain that interviewers would love to hear that you have some knowledge with all of the main build systems and the meta build system CMake that people actually use in industry. That would make your life probably quite a bit easier. I will also say last year, some students got a few of their features done so quickly that they actually grabbed another one off the shelf. They did two. Very impressive stuff. You can think about creating a rare or exotic platform export. We had a lot of WebGL builds last year. WebGL builds, like web builds, are awesome. Love playing games in my browser, as you can probably tell. I don't think we saw any Android or iOS builds, which would be a super cool kind of rare export. So that could be a really interesting challenge. We had some students who altered their JSON-based kind of configuration files and made them binary instead. Why would you want to do this? Any ideas? Now, they become less editable, but you gain what?
Fast loading times.
Yeah, things get a lot more space efficient. They load into memory quite a bit faster. And so it is a very interesting experience to go in and try and optimize your engine more. One challenge is if you're going to use binary configuration files, you need a tool to help you edit those files now, right? Otherwise, not a whole lot you could do. You could have a pipeline where you write everything in JSON, and then you have a little tool you run to convert them into binary files, and then you load them in. Yeah.
Kind of seems like if you're going to do that, you also should be making a scene editor.
Probably, yeah. But whatever you want to do. You can, one of the options in here is you can say, hey, I really like game design. I feel like I'm more in the gameplay design thing of kind of things. Let's go ahead and let's just make kind of a 494 Project 2 style game in our engine. Okay, that is valid as well. It doesn't have to be new features for the engine. But what will happen is that as you go and try and do real deal industrial things in your engine, you're going to find that you want some additional features. Okay, so you will end up adding some features. Basic networking. A couple students last year did this. They had a great time. Okay, SDL provides some networking technology that is cross-platform and kind of nice to use, I hear. And so if you want to create a multiplayer networked game in your engine, you can give that a shot. Okay, you can get a little taste maybe of the one day upcoming EECS 404 cloud computing and live ops course, okay, where we teach you all how to make multiplayer games. That'd be awesome. there's a very, very common UI library. It's called Dear ImGUI, and you'll find this all over the industry. A lot of AAA game engines use this, and they use it to very easily display things in their engines, right? So if you want a really, really quick way to get a little debug menu that allows you to just quickly change properties or numbers or whatever, or click a button and run some code as on a callback on that function, right? Or a callback on that button. You can do that, and you can actually see how simple the code is, right? You can create a little application here. You can create a menu bar, add items to it, save, open, close. It's just that easy, a few lines of code, but it is a library that you'll need to integrate without the staff help, okay? So a good exercise, if you want to give that a shot. We had some students try and build their own game editor. In fact, Jacob, if you're in here, his initial shot at building an editor for his game engine in this course was just purely ImGUI based, right? So it would track all the actors, it would show you what components they had, and it would allow you to edit those components right there in the engine while you played the game and persist it all. So pretty cool stuff. We had some students last year who were very into audio. They were musicians. They wanted to take a crack at implementing technologies such as Wise and Fmod. So Wise and Fmod have very popular export options into Unity and Unreal, but they also provide a general purpose C++ integration for people like you who are making their own game engines. And so possibly if you're really into audio, could be an interesting thing to do. The custom feature, hot loading. Does anyone know what hot reloading is? What is it?
You're in the middle of an execution, you update a script, and then you immediately apply the updated changes to the execution.
Yeah, I'm playing this game, and I could shut it down and then make my changes and rerun it, but I might lose progress. My testing slows down. So on The Sims 4, we had the ability to write gameplay code in Python, and then we had a command in the engine that would reload all of that Python. We didn't have to end the game. We didn't have to load out of our current map. Not all of the code would work if you went back in and did this, but a lot of it would, and it allowed us to kind of accelerate our development process, okay? You have a lot of control over the Lewis state. You can clear that state if you want to, okay? You can mess with that however you want to. And that's how you can do a hot reload if you want to. Go ahead, Jose.
I was going to ask. So one of my ideas for the research thing was kind of, you know how a lot of games have some sort of because the game isn't going to end like an hour, or at least not a lot of games end within the span of an hour.
Yeah.
So you need some way of saving both players' progress.
Oh yeah, persisting and
persistent data. I might look
yeah. Okay.
Data just to
Yep. Okay, so if you recall. The RenPy visual novel engine gives you these saving and loading features for free. Okay, you don't have to do anything as a game designer or a game programmer to actually get those nice features for free. And your engine could do something similar, right? Possibly it might be hard to make that work for every style of game, but
I did have a couple ideas which
Yeah.
where the research comes in. What
Yeah.
I call active or passive saving.
okay.
That is it. That's like
Yeah.
look into that for research. Thing.
Yeah. So what I'm curious is it possible to serialize and then deserialize a Lewis state? Because if you can,
That's what I was thinking.
yeah, if you can, like the game is Lua.
So
The state of the game is totally Lua, except for maybe the box 2D stuff.
So my question, that would be a research thing of how can I turn, because with serialization, you have to turn one object into another, and
Well,
turn the other.
No,
Like,
you're essentially you turn
yeah.
one object into like straight text and then
Yeah.
save the text to a
Yeah,
file.
or possibly a binary format or something.
So not impossible, but
Yeah.
I'm wondering what foot gun that to avoid, so I'm not just saying.
No,
okay,
you
Well, yeah.
can definitely do it.
That's the research question, right? That's
Yeah.
why we want
So-
you to get out there and explore.
I'll look at both. That's actually
yeah.
also something interesting.
As far as I know, Bethesda's engine offers pretty good support for saving and loading arbitrary stuff.
Case
Two.
in point, the Oblivion RAM. Was it Oblivion that they had the RAM hack for Xbox? They just-
Oh yeah, that's right. Yep. There's a memory leak patch. This is one that if you enjoyed the Homework 9 assignment, if you said, Austin, your staff solution too slow. And I actually agree with you. Like, I'm starting to get the feeling that I'm good at certain things, but I'm not necessarily good at writing super fast C++ code. Because I'm getting my butt kicked by a bunch of students on like their first try. That means good news for people who haven't started, right? But if you're really hungry to accelerate your Homework 9, your particle system, or other parts of your engine even more, one of the great things about data-oriented design is that it makes things highly parallel. Your computation is very highly parallel. Your particle at index 0 does not care about or interact at all with the particle at index 1. So you can easily just kind of split your array of particles or whatever objects you care about processing into, as many different sections as you have processors. And then you can just sick them on the computation. You can speed things up dramatically. And so there are other parts of your engine that might be amenable to this kind of thing too, especially if you can afford to break certain rules on sequencing. So maybe, there's no guarantee about which components will run before other components in the on-update loop. Maybe that makes it a bit easier to multi-thread some stuff. I don't really know. You need to go experiment. But yeah, for those of you who really love performance and optimization, that's the clear winner right here. Go get some interesting multi-threading stuff going on. And in particular, Nathan Hainish at Stardock, their lead technical guy, is like, oh yeah, that's the next step, right? Because game engines these days, they need to be multi-threaded. They need to be very highly parallel to get optimal performance. Again, our processors aren't really getting faster in a single-threaded sense, but they're getting much more broad in that they have many cores with which to split up parallel tasks and move faster that way. Okay, an additional scripting language, right? You don't like Lua? Try Python. Or, and this would be the coolest thing, hey, this engine is awfully similar to Unity in a lot of its design choices. Why not try C#? Let's try and embed C#. Why not? How's about it? 3D rendering support is one of the scarier challenges, but those of you who love graphics might be a really interesting and useful challenge. We did have a couple students succeed last year with it. And OpenGL 2, which is what we're using, does not have a cross-platform 3D API. There's no function like STL render copy X for you to use, but 3D, okay? STL3 does have that, but it's a kind of basic. So what you'll probably have to do is you'll probably have to get the OpenGL libraries downloaded, and SDL does provide some support for OpenGL, interfacing with it, getting that working. But OpenGL might not work on all the platforms you need, right? You try and launch on Mac, they have a very old version of OpenGPL. Maybe it will work. OpenGL. And Windows is always kind of a pain to set up OpenGL on. But on Linux, you'll be set, so at least you have that. How many of you dev on Linux as your main platform? Okay, you and only you are set. There you go. All right. And then, of course, you can make your own custom feature and idea. It does need to have some significant technical work that you need to do. But if you have an idea and you're wondering whether it's going to be a good fit, just come ask, okay? And we'll give you our thoughts, all right? We're pretty generous with what you can do. We want you to have a really good time in these final 2 weeks. We don't want it to be too stressful either, because you're going to be doing other exams and prep for other courses and finishing other projects. So we can have a chill kind of final 2 weeks, if that's okay with you. Or, because this is technically a midterm exam, I could bring in a final exam.
4 weeks.
If the copy machine dies Thursday night and I can't get the exam printed, I might have to cancel the exam. Wouldn't that be just terrible? And none of you would speak of that happening ever, right?
What
This,
predict-
yeah,
Wait, what
is the exam came, the exam went, and that's just how it was, right? That's all you need to say. Okay. Yeah, I promise the exam will be kind. Okay, it will not be a super mean exam. Okay, so I want to kind of wrap things up. And again, I apologize for this early lecture. It's such a new course. The lecture needs more time to bake. But I want to show you a little bit more about coroutines. And in particular, for those of you who have forgotten, you haven't used them in a while, or if you've never heard of coroutines, this is coroutines from the Unity/EECS 494 perspective, okay? In EECS 494, our students have a big challenge. One of the things they need to try and do is implement game mechanics that you can't pack into one frame, okay? It cannot be done. And I'll give you some examples, okay? These are actually shockingly hard things to implement, just going in the normal way, okay? Doors, room transitions. How many of you have played Legend of Zelda? How many of you have not done any coroutine stuff? Like you're new, and this is like weird 494 business. What is this guy talking about, right? So I want to show you a really tricky mechanic that's really important, okay? Watch this. It's going to blow your mind. Okay, not this. Okay, watch when we go through this door right here. Ready, 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 go. Woo! Woo! How about that, right? Pretty intimidating. Okay, so these room transitions don't look that spooky from the get-go, okay? And these transitions are extremely popular in games. They're popular these days. They are popular in games back in the old days, right? Here's Metroid. They have their own room transition. Right? Controls turned off, move the camera, enable Samus, okay? So what's the problem here, right? What makes these a true pain to implement? Well, there are a couple things that are subtle here. In general, in our game engines, we know how to detect that we've touched something. In Homework 8, you implement a function called onTriggerEnter, okay? When the character touches an invisible trigger near the door, we start moving to the next room, okay? You know how to do something like disable player controls. That's pretty easy. You can just have a global Boolean and flip it on to enable controls, flip it off, and now the player cannot move, okay? When the player gets their controls back after the little cutscene, that's easy too. You just kind of flip the Boolean again. The big problem is this part right here. Over 2.5 seconds, the camera actor has to be moved progressively, okay, to the other side. And that is the kind of thing that you can't implement on a single frame, can you? So how would you do this? Well, you could have a variable, a bunch of variables. You know, am I in the transition state? Okay, I've got a float. How far am I through it? And it's just really nasty. Combine those variables with the update function and you can make it work, but it gets nasty fast, okay? We would like to be able to write much better code, okay? We want to be able to write a simple single line of code that makes this happen. And it's really hard to do. Here's the takeaway, the general statement. Temporal mechanics that span multiple frames are kind of nasty and tricky to implement, okay? And they're so common in games. Very often in games, you'll have an animation where, oh, I found an item, I want to pick it up. You don't want to pick it up instantly. You want to trigger the animation, you want to wait, pause for the player to go down, wait for the animation to finish, the animation's finished, now load that item into your inventory data structure. Yes?
Monster Hunter Beat Life was the best way to
Really?
You have 5 frames to pick up something, but if you get hit before that, you don't get the item.
Yeah. Dark Souls, Demon Souls had the same thing. If you're at a fog door, you have to kind of stand there and kind of slowly go through it, and you can get stabbed right in the back. Brutal, okay? You could use things like threads, okay? You could launch a thread that will manage this door transition, this room transition, move the camera, and your initial thread can just block on it or join on it and just wait it out. If you're in EECS 482, that's going to be the hammer you grab from your toolbox to implement this. You can try using something like thread.sleep to freeze the thread, but freezing the thread in a single thread engine like Unity will freeze the entire engine. The entire game will break, okay? Not a good idea. You might think about an advanced feature like await, but usually, well, at least in C#, this is not an option because Unity does not support the version of C# that introduces await. So very sad. And so here's the code we would really like to be able to do, okay? In onTriggerEnter, our lifecycle function, okay, that the engine's going to call for us, we're going to check, did we hit an object called door west? If that's the case, it would be awesome if we could just call a function that does that transition, okay? The function could look like this. We're going to turn those player controls off. We're going to wait for 2.5 seconds. We're going to move the camera game object over 2.5 seconds. And then when this line of code is done, we're going to turn our controls back on. Now, this looks way cleaner than having a ton of variables and Boolean variables and float variables, and we're using update function, so it's all scattered around there and nasty, right? Yeah. Nasty. You can create a state machine class in architecture, which is better than nothing, but still kind of messy, a lot of work, okay? Why can't we have this? I want to be able to write a normal function where sometimes my line of code can just chill. That's all I really want, okay? It kind of brings the magic of single-threaded programming to a more asynchronous situation, which is just really nice. This is going to fail, okay? The big issue is that we can't implement this function. We don't know how. With just normal code, we can't do it, all right? And so we need some way to pause this line of code and let other things run during this transition that's happening, okay? And so thread.sleep will just pause the entire game. That doesn't work. We can't create another thread, okay? We could make a state machine class, but here is the best solution, okay? We're going to use a feature called coroutines, and many languages support coroutines these days. C# does, Lua does, okay? Especially once we add our Lua manager to actually make it usable, right? And this is that version of that function, okay, that we wanted, all right? Here is our first coroutine, okay? What do you think this code does? And I want to get hands from the people who have not seen this lecture from 494. Raise your hand when you know what this does. When you have a guess as to what this does. Okay, got a guess? I don't want you to tell me. I want you to act it.
I don't know what it does.
You don't? Can you guess?
I didn't take 494 or any of that.
Can you guess based on what we've talked about so far, how this works?
Okay. I'm guessing you're going to enter this delayed below function.
Okay.
You're going to end at, you're going to arrive at this new wait for seconds.
Okay.
So you create it,
Okay.
and then you're going to yield it. So that wait for seconds is going to happen 3 seconds later. But then you'll keep moving down your code.
Yep.
And then 3 seconds later, that function will call. I guess it's kind of like an async await thing.
Kind of, yes. So, Jose, thank you for volunteering to act it out. Thank you so much. Okay, go for it. Ready? 3, 2, 1.
Hello. There.
I don't think that was 3 seconds. I think it was 2.
My internal clock is usually off.
Okay.
So just count it off. For like 3.
Okay, excellent. All right, that was almost perfect. Okay, good job. All right, so yes, basically how this works is that the start lifecycle function is called in the exact same way that the onStart function is called in your engine. It's just lacking the on in Unity. In any case, we call our coroutine functions via the special start coroutine function. This is a function we have to use in order to register that coroutine so that Unity can actually bring it back to life on the next frame. All right? And so we enter this function, this coroutine function. We print hello right away. We then hit the yield return keyword. You can think of yield return as kind of one word, one keyword. Okay, you got to use them both. All right? And what are we returning? Well, we're returning a cool new object called wait for seconds 3.0. This is a special object that's been programmed to delay the coroutine that calls it for 3 seconds, or however many seconds you specify. All right. Then, as soon as the 3 seconds is up, this coroutine comes back to life and it finishes up with there. So, hello, there, right? And so, pretty simple. A quick thing to note, at least in C#, you know a function is a coroutine because of its return type. IEnumerator, a very special return type. This allows the compiler to chop up this function into little bits and pieces that can be replayed, which is how the coroutine works under the hood. Okay? All right. So, cool, right? Well, let's try a more challenging coroutine. Okay? This is a coroutine that has quite a bit more logic to it. And it has actually a coroutine that calls another coroutine. By the way, if you ever forget to use start coroutine, your function is just toast. It's not going to work, okay? Nothing will bring it back to life. So, who is just dying to act this one out? Ready? Okay. 3, 2, 1.
Hello. There.
I love how little gap you put between the first hello and the first because there's nothing to slow it down, right? They're going to show up on the same frame. All right? Well done. Good job. Good job. Okay, so, right, we have our lifecycle function, which is just very normal. It launches a coroutine. This coroutine prints hello. We then yield return, not on the wait for seconds object, but for another function, okay? We're going to start another coroutine. We're going to wait for it. We're going to yield to it. That basically means just block until this thing's finished. We're going to pass in a 3, okay? 3 comes in here as a parameter. We're going to go around this while loop. Every time we go around, we decrease the number of notes, and we yield return 1 second, okay? After a second passes, we go hum again. We decrease it, hum again, decrease it, okay? Now our number of notes remaining is 0, and we bail. The coroutine ends here. We go back up the call stack, and we come out right here and print there, okay? And there you go. So, pretty good, huh? Things are getting really complex now. You're feeling very confident with coroutines, but I have another one for you, okay? Oh my God. And this is the kind of coroutine that actually is super useful. It looks intimidating because this is actually a library function that is super general purpose and easy to use in many different ways. So my recommendation to you is when you read this funky library function, okay, make use of its name and the parameters. It'll tell you what the function does, okay? Then you can see this function being used down here in the actual gameplay code, and you can give me what you think this is going to do. Any ideas? Now, a bunch of you already know what this does. Yeah, non-494 students. Show your might, your muscle. And I'll see you in class next semester for your capstone. What do you think this does? Any guesses? What it does is actually not too crazy. Any ideas? We got 20 minutes to stand here. If you need a few more minutes, that's fine. Office hours begins when we get this question right. So you took 494, right? One thing to note here is that it looks like there's a ton of code, but this is one function. This is also one function. There are really only 3 function calls in this body of this if statement. Simply read the name of the function and make a guess as to what could be happening. I'll remind you of the challenge that I showed you at the beginning. Room transitions, right? Okay, what do you think?
I'm not in this class.
Go for it. Yeah.
Would it just be jumping?
Jumping?
Yeah.
Okay, almost. You could say that something is moving, right? But what? Yes.
Looks like you wait for a space, and then when
Yep.
that happens,
Okay.
you move to position 20, 0, -10.
Okay, which is to the right of us. Okay.
Okay, you move.
Yep.
And then you wait for 2 seconds, and then move back.
Bingo. Okay, and here's exactly what happens. We wait until the user presses spacebar, and then, oh my goodness, this component was on the main camera. It was a room transition the entire time. Okay, we're in another room, and now it comes back, and we have this nice temporal mechanic that does what we wanted in our little, 494 project once. Okay, so let's read through this really quickly, and I'll walk you through it. We launch a coroutine that does the unthinkable. It has an infinite while loop. Okay, you write this in your EECS 183, 0 style points. Failed the test case, right? But here, it's actually not a problem. An infinite while loop usually breaks your program. It hard locks your program, but not in this case. Why? Does anyone know? This is a coroutine. It's all about running a chunk of logic that can then wait, yield, let other things run, okay? The reason this while loop doesn't doom us is because of this line at the bottom right here. Yield, return null. This says, hey, I did my iteration of the while loop. Let me wait and chill to the next frame. And in the meantime, I'll yield to everything else that wants to run. That's how a coroutine works. It's a function that can chill and just chillax for a bit. Yeah.
So then I guess, so it's like so the way I'm thinking of it is it's like a function within a while loop that just will return. That'll just return sometimes, or otherwise it'll do stuff.
Yeah. This is a function that at any moment can just chill, take a break.
Yeah.
Let everything else in the entire code base run. Okay? And then when we're done chilling, we can come back.
Just like a continue or something.
Yeah. Yeah. So, okay. What we do here is we have a couple positions. Our initial position, this is where the camera starts, because this component has been put onto a camera. We could put it onto an enemy or anything else, but we put it on the camera. And so we're going to call this coroutine right here. We're going to block. We're going to wait for this coroutine to finish. What is this coroutine? Move object over time. Which object? My current object. Okay? Whatever object I've been put on as a component, whatever actor I've been put on, I want to go from my initial position to my final position to the right of us, and I want to do it over 2.5 seconds, okay? If you look over here at the guts of the library function, you might not know what's going on in it. It is a bit of math. Very simple once you've done it a few times, but this bit of math over here is basically calculating a progress value, 0% to 100% over time. And as this progress value goes closer and closer to 100%, we are going to lerp. This is like the mix function from homework 9. We're going to lerp further and further between initial position and destination. In other words, this function is going to move our object between 2 points over the amount of time that we specify. Okay? And so we call this function, we wait on this coroutine for 2.5 seconds, we move, and then once we're there, what do? We chill there for 2 seconds, and then we call the same exact function, almost identically, except what has reversed? Our initial position and final position has swapped, so we're simply going back. okay? And then we're done. What happens if I press the space bar during this cool animation where the camera is moving and then thinking about coming back and then coming back? What happens if I press the space bar?
Nothing happens.
Nothing. Nothing happens because the check for the space bar is happening up here. And for most of our time, we are yielding. We're chilling. We're not even running this line of code every frame, okay? We are just chilling and watching our coroutines do their thing. And so, there you go. This library right here is a great function because it can allow you to move any object from point A to point B over a certain amount of time that you specify. That's a really common thing in games, okay? And once you've built this once, you can just reuse it over and over and over again. You don't even need to understand it. As long as you can read its name to figure out what it does and fill in the right parameters, your teammates can use it without really diving into the math, okay? You had a question?
Yeah, so this kind of goes back a couple weeks. So like for our engines, we have like the, what's it called? Like the event queue or whatever.
Yep.
So,
Event queue.
so is that how kind of this works out? Since you hit space while you're on a different frame that's not checking the input, it would just kind of vanish into nothingness.
Yeah.
Not do anything.
Yes, yeah. So the way that Unity's input system works is the same way that all of ours works in our engines. Like we pretty much just recreated that API. And if the player presses the space key and you're not checking for it that frame, well, sorry, it's gone, right? It's no longer going to be true in the next frame unless the player picks their hand up and presses it again, okay? So yes, yeah, good thought. In fact, Unity uses SDL. I proved that to you not too long ago. And I would be very surprised if the Unity engineers didn't implement their input manager in basically the same way you did. Okay? It's kind of a powerful feeling, isn't it? It's kind of like, hey, maybe the company should hire some people in this room. That would be a pretty good idea, I think, actually. They could use some help. Okay. So here's what you get. And so you see, we have kind of a nice, little bit, more straightforward, not super simple, but a little bit more straightforward of a way for us to order things up. Our little to-do list. I want you to move over here, wait for a little bit, and then move back, right? No need for threads, no need for a bunch of weird state. It's just basically a simple function with a few functions inside of it that make it do things. And the only difference is that our functions can chill and wait and let other things run. Even in a single-threaded environment, we seem to get multi-threaded behavior. It's not multi-threaded, but it feels that way, okay? Here's another really great coroutine. This one is super cool. In The Legend of Zelda, there are certain rooms where the door won't open until the enemies have been defeated. So, how can we implement this? Well, we could have an on update, and every frame we're kind of checking how many enemies there are. Nah, it's boring, okay? And it's kind of messy, too. What you can do is you can have a coroutine that will wait forever until you defeat those enemies, okay? And then perhaps after the coroutine is done, you can then unlock the door. So here's the coroutine. It is an infinite while loop because we can wait forever when we might want to. And what we're going to do is we're going to grab all of those enemies that exist in the scene. This is kind of like your actor.findAll function call. It's kind of inspired by this. We're going to check how many enemies did we just find. If the answer is 0, i.e. there are no enemies left, boom, we're done. We're going to break out of this infinite while loop, okay? End the coroutine and move on with our lives. Open the door, okay? Otherwise, if we're not done, i.e. we have enemies that still exist, then we can do yield return null, and this is basically a one-frame yield. You'll yield the rest of the frame. So everything else can run, but on the next frame, we are going to resume, and we're going to check to see if those enemies are gone. Okay? Go around the loop again. Okay. Any questions? Okay. Why is the following code going to fail? Any idea? And this is kind of a coroutine thing. It's a very easy coroutine bug to create. coroutines are all about their ability to yield, to let other code have a bit of the action. But this coroutine is a little bit greedier than your typical coroutine. It's going to cause a problem. You run this code, you get a freeze. Your Unity editor is going to freeze, okay? If you are running your engine is going to freeze, okay? The entire Lua interpreter is going to buckle up and keel over. What's the issue?
Is it because the progress can always be less than 1, so that loop will just go on forever?
Bingo. Absolutely. Progress, right here, progress. This progress calculation is what allows us to eventually break out of this while loop when, eventually, the time progresses enough. But here's the thing. In this while loop, we calculate progress using the time.time value, and then we finish the loop and we go around again. We never give any other system in our engine, in Unity, in this case, time to run. And so time.time is a value that never increases, which means that progress never goes up, which means we never break out of the loop. So how do we fix this? Any ideas?
Is the time.time not giving you like current system time?
It's not, no. In Unity, it gives you like an internal calculated thing that will be accurate so long as you let it run.
Okay, so I guess like switching that to a current system time would work.
That would work, yep. But it's not the ideal solution, I think. What else could we do? Yes?
You could just really yield return within the while loop.
Yeah, exactly. The big problem here is that this while loop does not give the rest of our code base, the rest of our engine, an opportunity to run and update itself. It just hogs everything. And so how do we fix this? We just add a yield return null here, okay? This breaks the infinite loop. This allows this entire component to chill. The time system can update now, and now time.time is actually growing, which means progress is growing, which means we eventually break out of this loop, okay? So it's not critical that you understand all these examples, especially if you're not an EECS 494, because, hey, you're not an expert on Unity. You want to become an expert on Unity, you take that course. But I hope you can see that this notion of coroutines is a really important one when it comes to expressing gameplay ideas, okay? Any gameplay mechanics or logics or ideas that span multiple frames, they are temporal mechanics. Coroutines are a really good fit for those, okay? And it's not the kind of programming you're used to from like EECS 280, EECS 281. Like in EECS 281, how is it? You write this chunk of code, and you just want that code to run as fast as it can, okay? It's going to have one frame, all right? You run as fast as you can. The entire program runs in one frame. One frame. Depends on what you consider a frame. And this is different than that, okay? We have logic, bits of logic that can chill, that can peace out and let everything else run. It is simulated asynchronous programming, okay? And it's extremely powerful. Does anyone have any questions on the topic of coroutines that are really gnawing at you? I have a feeling they're still very mushy, especially if you haven't taken 494. That's okay. The kind of questions we're going to ask on the exam are going to be really lightweight, okay? Basically just like, what are these used for? Probably. Maybe I might even ask a question like, there's this concept that allows game designers to express temporal mechanics. What's that called again? Is that a Go routine? In the language Go, made by Google, I think that's actually what it's called. So I couldn't put that as a option, because then a student's going to come up and say, Austin, this is actually correct. Both options are correct, and they're going to be right. You know how hard it is to recall a bunch of paper exams that have gone out that I haven't recorded? Well, that's not going to happen. Okay, it's not going to happen. It's going to be a very manual process. Question?
I guess like how does this whole coroutine concept compare to something like async await in Python?
I haven't really used it, but my impression is that usually async await like actually does involve like different threads.
Doesn't
right?
have to.
It doesn't have
I
to.
think that
Okay.
JavaScript has async await and it's
Okay.
all single-threaded.
So here's an anecdote. Here's a cool anecdote. Okay, watch this. In the May and Mags web game, I had to get myself some coroutines because I was going insane trying to program the cutscenes. And so I'm going to go and show you what happened. I go to page source. I'm going to search for minigame.js. There it is, right there. Okay, let's go find my coroutines. Let's go find cutscene or dialogue. Where is it? By the way, didn't I tell you that one person in the room had a game engine all in one file? All right. Okay. So we have this do dialogue function that is like cutscenes and stuff. And you can see I'm using await here. Now, basically, I kind of programmed, I want the actual function. These are just cutscenes I kind of programmed in. Okay. Where are they? Here it is. Okay, it's an async JavaScript function, do dialogue. It takes a bunch of stuff. You can expedite it if you're holding space. Okay, and how does this actually work, though? Because I've forgotten it. It's been a long time. Okay, it's got an array. How do we clear the dialogue? Player wants speed. That's a cool variable. Create Java text, blah, blah, blah. Oh, wait. So it's using the promise system in JavaScript. This is a way, I believe, to basically get JavaScript to chill. Okay? Await allows you to kind of do coroutine-like functionality, and then a promise is kind of like a function that is allowed to take a certain amount of time, and when it finishes, you return to it, right?
I guess the whole concept of this is that whenever you make a promise, you give it a time that it's going to run.
Yeah.
Your program will continue running, and then let's
Okay.
say you tell the promise to run 2 seconds later, your program will keep running, then 2 seconds later,
Yeah.
it'll interrupt, go
Okay.
run the promise,
Yep.
and jump back.
Cool. Yep. So, yeah, that was the hacky way I was able to kind of recreate coroutines in this JavaScript engine. If you read through this nasty source code, you'll find it has a basic component system set up with its own lifecycle functions. And the reason I had to do this is because the physics that I wrote for May, the character, I wanted to give it to other enemies and a boss fight in the game. And I was like, I can't duplicate this code, so I had to rip it out into a rigid body component so I could plop it onto May, but also plop it onto the boss enemies and some other enemies that can actually move around and deal with physics and stuff like that. A rolling spike ball, jumping rabbit enemies. Not sure if those are going to stay because that doesn't really fit the theme, the athletic competition theme. But anyway, so yeah, you can read through my nasty-ass code if you want to and feel better about yourself, I guess. Yeah, I was just really lazy. I finished game engine architecture last year, and I thought I really want more people to take my courses. So you know what I need to really get a lot of attention and enrollment? I need all my course websites to have a game on the top. And this is just going to guarantee perfect enrollment forever. Not sure what I was thinking. Okay? And I have no idea. Anyway, what I'd really like to do is right now the game is the same for each of these courses. I want them to be customized to the course. So you get a different game in the banner depending on what course site you're looking at. I think that would be sick. Need to get more stickers, though, for people who cleared the games. Yes?
We love brute forcing engines. Sometimes it just comes after that when it happens.
Yeah. You know what the collisions in this game, May and Mag's game?
Is it just a basic...
It's not Box 2D. What is it called again? It's AB.
Oh, I was thinking
right.
it was going to be closer to the, what was the old...
Hotspots?
Like the square root difference, the square radius difference.
Wait. No, I'm not using AABB. I think I'm using it for some things, but I'm actually using a different technique for May that's called hotspots, where basically you're just ray casting at a bunch of different places, and basically if this ray cast hits but this one underneath doesn't, you're against a wall, so you can't move against the wall, but you're gonna fall because you're not standing on anything. So it's just ray cast hell, basically.
The old, so literally Unity.
Yeah. And it totally works okay-ish. Sometimes you get stuck on like the corner of a block,
I reminded
and everyone goes crazy when that happens. I've gotten so used to it that I just have stopped caring.
if you remember like the zoomers from the Metroid P1 for 494.
Yeah.
It reminded me of like the hell we had to go through.
Yeah. Oh, yeah. Exactly. You tweak it, and you're like, this fixed one problem but broke another, and you can't get it quite right. You can never get it quite right. Anyway, all right. I managed to burn the entire lecture somehow. Okay. Well, thank you for obliging me on topics that are probably not as essential. But hopefully, if you've forgotten what coroutines are, or if you've never heard about them in the first place, these are seriously awesome tools. And I'm actually, when the summer arrives, I'm going to put them into the A2 engine so you just get them for free. They're just that useful. Okay. No, you got to wait for like 60 seconds before you can write on the board. Yeah. What's up?
When you say you're going to add them to the A2, like a C++ component type of
Well,
thing? Or do you mean just like that?
Probably I'm going to add it as a table in Lua. In the Lua state, by just running, I'll do like a Lua_doString call with all that Lua code on one line, hard-coded in my engine. Yeah.
You know what? That's the way to do it.
Yeah, it's pretty epic. Yeah. It's a freely available and permissively licensed engine, but that does not make it open source. Okay? So no one's going to see the source code. Okay? For academic reasons, it's never going to happen, but you can still use the engine. You just can't fix any of my bugs I left behind. So, okay. You could if you hacked the binary.
Yeah.
You could.
Yeah, decompiling.
Yes, if you really want to.
And I guess this is the issue with you having that whole,
Yeah.
I posted the A2 engine.
Yeah.
What if someone just decompiles the whole thing? Someone just...
Well, here's the thing.
Pro and
You can
decompile.
decompile it, but then at some point you're going to have to submit it to like the version control, and I'm going to see your code, and I'm going to have some questions.
Even then, like, generally, if someone's
Gotta obfuscate
like
it.
disassembles it and like completely
Yeah.
reconstructs the source code,
It'll
it's
look
not
different
gonna
enough.
look the same source code as what you made.
If you
It's
do
gonna be some
that,
source code that compiles with the same sentence.
yeah. Hey, congratulations for failing. Good job. So I got a sticker for you. Did you already get the sticker?
I got the victory one.
Oh, you got the victory one. Okay. I was watching you play through all my games the entire lecture.
Oh.
And so I'm trying to like think of the next thing I want to say while I'm also like taking a peek at like how's he doing. Yeah. There you go.
Wait, isn't there a participation trophy?
Yeah, it's this one. If you get the bad ending, you get Magna. Yeah, because she won the tournament. Yes, because she wins the tournament.
Okay.
So there you go. Pretty easy to get
I
if you
got
want
stuck in dog the other day.
it. Okay, well you got to show it to me.
I'll be back.
Okay, all right, sounds
Yeah,
good.
then I guess the other thing I was thinking of was the
Have a
whole
good weekend.
Hey, take care.
It's like the whole custom feature thing. I was honestly thinking about going
Yeah.
the whole saving serializing thing.
Hell yeah, that sounds cool. Sounds awesome to me.
And the thing is that it's not just for saving, because
Yeah.
you need to serialize in order to do multiplayer as well.
Yeah. Okay, I need to end the stream real quick. See you, everyone.